In Learning Assessment 810, our task is to compute Z sub t, and we're going to use the problem-solving strategy entitled Combining Impedance and Admittances. And if you look at that strategy, it says that we should add admittances of elements in parallel, we should add the impedances of elements in series, and then we should convert back and forth between admittance and impedance in order to combine neighboring elements. So we're going to start over on the right and work our way back over toward the terminals Z sub t. So let's look at the elements, some of the elements that are in series. We basically have series combination here. I'm going to call that impedance Z1, and then here we've got another set of impedances in series. I'm going to call that one Z2. And if we calculate then Z1, 2 plus J2, and Z2 then is 4 plus J6 minus J4 for 4 plus J2. So there's our first step, is to combine those in series. Now let's redraw our circuit. So here's Z1, here's Z2, now we have two elements in parallel, so let's go in and let's calculate Y1 and Y2, and then we can combine those in parallel by adding them. And if you remember, admittance is reciprocal of impedance, so Y1 is 1 over Z1, so that's 1 over 2 plus J2, which is 0.25 minus J 0.25 Siemens, and then Y2 is 1 over Z2, which is 1 over 4 plus J2, and that's 0.2 minus J 0.1. And now let's add those together, and we'll call that Y12, which is Y1 plus Y2. So we have two admittances in parallel, we can add them together, and we can see that this is 0.45 minus J 0.35. So now let's redraw our circuit again. Now let's calculate Z12, and then we'll have this impedance in Z12 in series. So Z12 is 1 over Y12, which is 1 over 0.45 minus J 0.35, which is 1.38 plus J 1.08. And now ZT is 2 plus Z12, and that is 3.38 plus J 1.08 ohms.